we are diving into the ID3 algorithm. Let's talk about what this algorithm does and how it works. It is a key method for generating multiple decision trees in AI, and ID3 stands for Iterative Datomizer 3. Okay, it's one of the most early algorithms in decisions tree construction, laying the foundation for more advanced algorithms like C4.5 algorithm. Okay, let's move on. So here's a history for the algorithm, and as it was invented by Ross Quinlan. Quinlan was a computer science researcher in data mining and decision theory. He received doctorate in computer science at the University of Washington in 1968. Here's a short history about this algorithm. As we know, if we are learning something, we should also be familiar with the history of how it came to life and who created this. Anyways, let's move on. So what is ID3 algorithm? ID3 algorithm is used to generate decision trees, as we know, which are tree-like models that classify data based on its attributes. And a decision tree is composed of decision nodes. Okay, and these represent attributes and split the data into branches based on their values. Okay, and then there's the leaf nodes. These leaf nodes provide the final classification or the output, and each node can have two or more branches, and these branches represent different values for the attribute being tested. Once we hit a leaf node, we get a homogeneous result. As we can see, a homogeneous result, meaning that all the data points in that branch fall into the same category. Let's talk about the algorithm. The algorithm follows the Occam's razor principle, which basically means it tries to create the simplest decision tree possible. In other words, it prefers shorter trees because they tend to generalize better and avoid overfitting. Okay, here is how the process works: that it takes all the attributes of a dataset, calculates their entropy, and chooses the attribute that has the lowest entropy or the maximum information gain. This attribute becomes a node in the decision tree, and the process continues branching out until all the data is classified. Okay, so here is how the algorithm is made step by step. Here it says that create a root node for the tree. If all the examples are positive, the tree returns a single node labeled plus. Okay, and if all the examples are negative, it returns a single node labeled minus. If no predicting attributes are left, the root node is labeled with the most common target value. Moving on. Or, otherwise we can say let's select the attribute that best classifies example. This one's based on information gain, and this attribute becomes a decision node. For each possible value of this attribute, create a new branch in the tree. Okay, as we can see here, add a new tree branch below root, and if a subset of data along that branch is empty, assign a leaf node labeled with the most common value. All right, and continue this process recursively for the remaining attributes. I can repeat the same thing again. As I said, you should select the attribute that best classifies the example. This is based on what? This is based on the information gain. Then this attribute becomes a decision node. For example, this is the attribute that best classifies. and this attribute becomes the decision node. All right. Then for each possible value of this attribute, we create a new branch. Like here, we created a new branch below root corresponding to the test best attribute. Okay, for each possible value. And if a subset of data along that branch is empty, assign a leaf node labeled with the most common value. Subset of the data here, and then this. Okay, and we will keep continuing this process recursively for the remaining attributes as well. All right. Actually, that is how the tree grows, by testing attributes and making decisions at each node. For your information, yeah. Let's talk about entropy and what entropy is, and we'll keep moving on and learn about information gain eventually. So, what is entropy and information gain? Let's talk about it. Entropy measures the uncertainty or the impurity in a data set. Like a completely homogeneous sample has an entropy of 0, like we can see here, and an equally divided sample has an entropy of 1. Alright, so what is the formula? As you can see, the formula for the entropy is this, okay, where p plus is a proportion of positive examples and p minus is a proportion of negative examples. Alright, let's move on. Hey, we'll come back to this later on. Okay, we'll come back soon. Let's talk about information gain. Actually, information gain tells us how much we have reduced entropy after splitting the data on an attribute. The higher the information gain, the better the attribute is at classifying the data. All right. Keep remember these points, that the higher the information gain, the better that attribute is at classifying the data. Let's come to the example. Here we have a example, okay, with 9 positive values and 5 negative values. Okay, the attribute we'll be testing is wind, which can be either weak or strong. For weak wind, we take 6 positive examples and two negative, and for strong wind, we take 3 positive and three negative. All right, let's calculate. Suppose, according to my calculations, I get an entropy for the weak wind as 0.811 and entropy for the strong wind as 1.0. We can put all those data into the formula, where gain is the strong wind is equal to entropy with the strong wind minus entropy with the weak wind minus entropy with the strong wind, and so calculating all of this, we get the information gain as 0.048. And here also we have sorry, I have just explained my own example, but here we have a different example which shows us the same methods, like that. Simple as that. And plus 14 comes by the addition of these two. Okay, here's a wind example that I explained. As you can see the wind example now, you can pause the video. Let's move on. Let's talk about the advantages. So we'll look at the advantages, where there are understandable rules, that the decision tree created by D3 provides simple and interpretable rules for prediction. It builds a tree quickly and efficiently, often resulting in a short tree. The algorithm only tests the necessary number of attributes to classify all the data, which makes it computationally efficient. However, there are some disadvantages to it as well, like this. where ID3 can overfit the data, especially with small data sets, which can result in a tree that's too specific. It only tests one attribute at a time, which can sometimes miss more complex relationships between attributes. And continuous data is tricky for ID3 as it requires discrete discretization, discretization, which can computationally be expensive. Overall, if you have any questions, you can ask me in the comment section, and let's wrap wrap up on the ID3 algorithm. It is a powerful tool, as we know, for building decision trees, but it comes with its own set of challenges like handling continuous data and the risk of overfitting. Anyways, if you found this video helpful, make sure to like and subscribe for more content on machine learning algorithm. Thanks for watching. I'll see you in the next video.